How's it, grade 11? So today we're going to be using our identities to solve expressions and stuff like that. But before I get onto that, I just want to go through the proof of fundamental identities. So we're working from slides 100 to 107 from the trig PowerPoints. Okay, so if we look at just an acute angle type of thing. So if I just draw something like this, and we have an acute angle theta. Now we know that theta, in terms of x, y, and r, will have an x value, a y value, and an r value. Okay. Now just remember that angle could be anywhere. It could be over there, over here, over here. Okay, I'm just choosing in the first quadrant just for simplicity. Okay, and this will have a coordinate of an x, y value. Okay, so if we look at the first identity that we've done, and that was tan theta equals sine theta over cos theta. Okay, how we prove identities is we always choose the left-hand side and the right-hand side, and we prove left-hand side is equal to right-hand side. So that is what I'm going to do here. I'm going to break it down, left-hand side, right-hand side. So tan theta is on our left-hand side, and sine theta, cos theta is on our right-hand side. Now, tan, we know in terms of x, y, and r is y over x. Okay. On this side, sine is y over r divided by our cos is x over r. And when we're dividing by fraction, we tip and times. So this will be y over r times r over x. Now you can see that the r's will cancel, and I've just got y times 1 is y over 1 times x is x. That is exactly the same as that. So left-hand side equals right-hand side. And we've proved it. Okay. If we go on to our next identity, and I'm not going to redraw this grade 11s, but I'm using this principle here with an x, a y, and an r value. Okay. So if we look at our second identity, which is sine squared theta plus cos squared theta equals 1. Okay, so left-hand side, right-hand side. So on the left-hand side, we have sine squared theta plus cos squared theta. On the right-hand side, we have 1. Okay, so sine in terms of x, y, and r is y over r, and that is squared, plus cos in terms of x, y, and r is x over r, and that is squared. So we get here y squared over r squared plus x squared over r squared. That gives us x squared plus y squared over r squared. They're both over r squared, and I've just rearranged it to be x first. Okay. Now, we know from Pythagoras that x squared plus y squared equals r squared. So this x squared plus y squared is equal to r squared. So we get r squared over r squared, which gives us 1, which is equal to our right-hand side. So left-hand side equals right-hand side. So we've proved that identity. What we're going to do now is we're going to use our two identities, the sine squared plus cos squared equals 1, and tan theta is equal to sine over cos, to answer the following questions. Okay, so our first one is example 1a. The question is, use fundamental identities to simplify the following. So we have 1 minus tan x times cos x times sine x. Okay, so we're going to use our two identities to try and simplify this. So the first one, always, grade 11s, try and change everything to sine and cos. It'll make your life a lot easier. So I'm going to leave that one, This one here I'm going to change using identity. So we know that tan x would be equal to sine x over cos x. So that's the first thing I'm going to do. 1 minus sine x over cos x times by cos x times by sine x. Okay, so this cos x will cancel with that cos x. And what we're left with is we're left with sine times sine. And that will give us 1 minus sine squared x. From our identity, this cos squared theta plus sine squared theta equals 1. We can get two other identities from this. And the first one is, if I try and solve for cos squared, I know that cos squared theta would be equal to 1 minus sine squared theta. The other one, if I solve for the sine squared, we would get sine squared theta is equal to 1 minus cos squared theta. And we can use these to help us simplify things. So for example, here we have 1 minus sine squared. There it is, 1 minus sine squared. We know that that's going to be equal to cos squared. So we get cos squared x, and we have simplified it. Okay, so just keep that in mind. Just remember the first one, the major one, cos squared plus sine squared equals 1. From that, you can get two other ones. Okay, if we look at example B, they're asking us to simplify 1 over sine squared a minus 1 over tan squared a. Okay, the first thing I'm going to do, change everything to sine and cos. So this one is fine. I'm going to leave it as sine squared minus 1 divided by. Now the reason why I'm doing this is because I can see I'm going to do a tip and times, because that is going to be changed to sine over cos. So here we're going to get sine squared a over cos squared a. So I've changed 1 divided to 1 divided like this, and then the tan becomes sine over cos, but because it was squared, both of them are squared. So this I tip and times, and it becomes 1 over sine squared a minus 1 times cos squared a over sine squared a. Just tipped it. Okay, so we get 1 over sine squared a minus cos squared a over sine squared a, because 1 times that would just give us that back. You can see they're both over sine squared a, so I don't have to get an LCD. And at the top we have 1 minus cos squared a. Now going back to this, I can see that 1 minus cos squared theta is sine squared theta. So I'm going to change this top one to be sine squared a over sine squared a. These will cancel and we are left with 1. Okay, moving on to example C. We have cos squared q minus sine squared q over cos q minus sine q. All right, so grade 11s, with ones like this, I can see that I'm going to have to do some type of a factorization thing here so I can cancel the bottom. So what I like to do is I let coses be x's and sines be y. Okay, so what do we have at the top there? Now remember what I said, let coses be x's, so we have x squared minus, let sines be y squared, all over x minus y. And if I gave you that instead, you can see that if I factorize the top in terms of a difference of two squares, it will cancel with the bottom. So what we would get here is we would get, if we factorize the top, x plus y, x minus y, all over x minus y. And you can see that will cancel with that, and we're just left with that. That is what I'm going to do with this. Okay, so at the top here, and I'm just going to use my substitution over here just to help me. Remember, x's are cos, y's are sine. So this would be factorized to be cos plus sine. So we have cos q plus sine q. In the other bracket, we would have cos minus sine. So we have cos q minus sine q all over this cos q minus sine q. These will cancel, and you are just left with cos q plus sine q. All right, and we can't take that any further. That's as far as we can go. All right, so let's look at example D. Again, they're asking us to simplify, and we've got, just want to bring up the question, we've got sine theta times cos theta over 1 plus cos squared theta minus sine squared theta. All right, so the first thing I'm going to have a look at is trying to maybe eliminate some kind of stuff here. Now, you remember from the previous page, we had cos squared theta plus sine squared theta equals 1. And then from that, I could get two other ones. I could get cos squared theta is equal to 1 minus sine squared theta. And the other one was sine squared theta is equal to 1 minus cos squared theta. And that is what I'm doing over here. I'm looking at the bottom here. Now, with the sine squared, if I make it 1 minus cos squared, can you see that that minus there would change the signs here? So we would get minus 1 plus cos squared. So minus 1 plus 1 will cancel. That is awesome, because now it's going to simplify the denominator. The top I'm not too worried about because we've got a product. And a product is always good because then we can just cancel things in the denominator. But the denominator is not so cool because we haven't got like that product situation there. We've just got the addition and subtraction of terms. So that's the first thing I'm going to do is I'm going to change this one to be this over here. So we get sine theta times cos theta, 1 plus cos squared theta minus, open up my bracket because I'm changing this whole thing to be that, 1 minus cos squared theta. Okay, and if I distribute that negative into the bracket now, you can see my signs are going to change. So the numerator doesn't change. We just leave it as sine theta over cos theta. Denominator 1 plus cos squared theta minus 1 plus cos squared theta. Okay, so these ones will cancel, and we've got cos squared plus cos squared will give us 2 cos squared. So we get sine theta times cos theta over 2 cos squared. Right, so 1 cos will cancel with 1 cos there, so we're just left with a cos at the bottom. And you can see that's going to give us a half. And then what have we got here at grade 11? So we're left with sine over cos. Sine over cos is tan theta. Okay, and we've simplified it. Right, guys, what I would like you to do is I would like you to do exercise 7.7, number 1 for me, please. Thank you.